Is space infinite? It's a question so simple, yet so overwhelming, that it has haunted human thought for thousands of years. Philosophers debated it long before telescopes existed. Today, scientists armed with supercomputers, particle accelerators, and space telescopes still struggle to answer it with certainty. At the same time, another mysterious idea dominates modern cosmology: dark matter. Invisible, untouchable, undetected, yet supposedly making up most of the universe. But here's the problem. The internet is flooded with misinformation. Dark matter is often described as hidden planets, parallel universes, or even proof of simulation theory. And space itself is casually called infinite, without explaining what that really means. Tonight, we strip away speculation. We follow the data, and we ask the hard question science is still wrestling with. Is space truly infinite? What is dark matter? And what is it not? And how big is the universe really? This is not science fiction. This is the frontier of human knowledge. When we say space, we often imagine empty darkness sprinkled with stars. But scientifically, space is far more than emptiness. Space is space-time, a fabric that stretches, bends, and evolves. According to Einstein's theory of general relativity, gravity isn't just a force pulling objects together. It's the result of mass warping space-time itself. Planets curve space. Stars distort it. Black holes tear it apart. So when we ask whether space is infinite, we are really asking, is space-time itself infinite in size? Or does it have a boundary? And that's where things get complicated. The universe is about 13.8 billion years old. Light travels at a finite speed, roughly 300,000 kilometers per second. That means we can only see as far as light has had time to reach us. This creates what scientists call the observable universe. Its diameter is about 93 billion light years. But here's the crucial detail. The observable universe is not the entire universe. Beyond this cosmic horizon, space may continue. Galaxies may exist. Physics may operate exactly the same, or completely differently. We simply cannot see beyond that limit. So when someone says the universe is infinite, what they often mean is, we don't know what lies beyond what we can observe. And not knowing is not the same as infinity. Cosmologists propose three main possibilities for the shape of the universe. 1. Closed universe, like the surface of a sphere. Finite, but with no edge. If you traveled far enough in one direction, you'd eventually return to your starting point. 2. Flat universe. Infinite, extending forever in all directions. Parallel lines never meet. This is what current measurements suggest, but do not confirm absolutely. 3. Open universe. Infinite and negatively curved, expanding forever. Current data from the cosmic microwave background indicates the universe is extremely close to flat. But close to flat does not automatically mean infinite. It means we don't yet have enough precision to tell. One of the most common misconceptions is that the universe is expanding into something. It is not. Space itself is expanding. Galaxies are not flying through space away from each other. Space between them is stretching. There is no center. There is no edge. Every observer sees the same expansion. So even if the universe is finite, it does not end in a wall, a void, or a boundary. This makes the concept of infinity even harder to visualize, because our brains evolved to understand rooms, paths, and borders. The universe plays by very different rules. Now let's address dark matter. Carefully, dark matter is not dark energy, antimatter, black holes, at least not in significant amounts. Conscious, interdimensional. Dark matter is simply a name for something that has mass, exerts gravity, but does not emit or absorb light. We know it exists because of what it does. Galaxy rotation problem. Stars at the edges of galaxies move too fast to be held together by visible matter alone. Gravitational lensing. Light bends around invisible mass. Large-scale structure. Galaxies form in patterns that require unseen gravitational scaffolding. Without dark matter, the universe we see could not exist in its current form. Let's dismantle the misinformation. Dark matter is not proof of a simulation, evidence of parallel universes, hidden stars, a conscious cosmic force. These claims are popular because they are exciting, not because they are supported by data. Scientists have searched for dark matter particles for decades using underground detectors, particle accelerators, space-based observatories. So far, it remains elusive. But absence of detection does not mean absence of evidence. It means nature is more subtle than we expected. Dark matter does not just affect galaxies. It shapes the entire universe. In the early universe, tiny density fluctuations existed. Dark matter amplified them. Normal matter followed its gravitational pull. The result is the cosmic web. Filaments of galaxies, massive clusters, fused empty voids. Without dark matter, galaxies would be smaller, fewer, and slower to form. The universe would be almost unrecognizable. Dark matter tells us about structure, not size. Whether the universe is finite or infinite depends on overall geometry, total density, early expansion conditions. Dark matter contributes to the universe's mass-energy budget, but does not decide infinity. This is where misinformation often fills the gap between uncertainty and imagination. Science is powerful, but it is not omniscient. We cannot see beyond the cosmic horizon. We cannot travel faster than light. We cannot rewind the universe beyond the Big Bang. And yet, we keep pushing. Every new telescope extends our reach. Every equation refines our models. Every unanswered question drives discovery. The universe does not owe us simplicity. So, is space infinite? The honest answer: we don't know. Space may be infinite. It may be finite but unbounded. It may be something stranger than both. Dark matter is real, but not magical. The universe is vast, but not fully understood. And that uncertainty is not a weakness of science. It is its greatest strength. Asking whether space is infinite isn't just about physics. It's about perspective. If the universe is infinite, then our existence is a statistical inevitability. If it is finite, then our location within it becomes deeply meaningful. Either way, we are part of something far larger than ourselves. Understanding the universe isn't about shrinking humanity. It's about expanding our sense of place. If you want clear science, not cosmic clickbait. If you want real answers, not exaggerated myths. And if you want to explore the universe as it truly is, subscribe to this channel. New documentaries every day. Deep dives into space, time, black holes, dark matter, and the limits of reality itself. Like the video, share it with curious minds, and leave your questions in the comments, because the universe doesn't end here. It begins with curiosity.